So you are welcome to today's live class. So we are talking about velocity speed and acceleration, but basically it is calculation involved. So let's discuss the first example, which is a student walk a distance of 3 kilometers in 20 minutes. Calculate its average speed. So so that is the so if a student is we want to explain now. Basically, today we are not going to talk much about definitions. We are specifically going to the calculations in physics. So we have been working through all examples related to what we are discussing today and calculate. So an average speed is distance to divide by time. That is average speed. We are waiting for those. So the live is public. So that is, we want to get the solution to this through what we have been able to see. So the solution to this, in your school, you're able to see that in solving, before you can be able to solve this, he said a student walks a distance of 3 kilometers in 20 minutes. Calculate the average speed. Now, the unit for average speed is meter per second. Please, if you are online, make sure you chat in the comment section. Try to say, "Hi, my name is so 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 so." It is important so for me to know that you are available. So now, there's something in physics that we call given values. We have been given some values. He said a student walks a distance of 3 kilometers. There's some given value like a distance which is equal to 3 kilometers. And remember, 1 kilometer is 1,000 meter, 1,000 of meters. So 3 kilometers will be 3 times 1,000 of meter, which will be equal to 3,000 meter. That is the distance. Why am I doing this is because the average speed unit, we call it a unit, it is meter per seconds. But we were given distance in kilometers. Distance in kilometers. So you must convert the kilometer to meter. That is the basic things you must understand in physics. So if our distance is 3,000 meters and we were given time to be 20 minutes, and remember that 1 minute is equal to 60 seconds. So telling you that 20 minutes will be 20 minutes will be yes 20 minutes will be 20 times 60 seconds, which is equal to 1,200 seconds. So that is just it. Now let's now apply the formula so we can able to get the exact value. So we have our average speed. Our average speed will now be the distance, which is 3,000 meters, over the time is 1,200 seconds. 1,200 seconds. So by the time you divide the both to give you 2.5 meter per second. So that is how we calculate the an equation given in this form. So basically, we are in calculations in physics, and we are here to solve many questions today. That this is where speed, velocity, and acceleration started. Please, I don't have much time. I'm using this opportunity to rewrite the second example to solve today. So the example 2, it said a driver traveling at a speed of 115 kilometer per hour receive a text message on its mobile phone. So how far is E in kilometers? That is 20 seconds. Later from when he received the text. So let's try to analyze this example 2 very well. He said a driver traveling at a speed of 115 kilometers per hour received a text message on his phone, on his mobile phone. How far is E in kilometers? That is, we are to calculate distance. 20 seconds later from when he received the text. So from this place, let's have our given values. There's something we call a given values. Our value given from here, we're given the speed. We're given speed to be 115 kilometers per hour. We're given speed. We're also given time. Time to be t is equal to 20 seconds. So if time is equal to 20 seconds, but remember, the question let us to know that our distance must be in kilometers, telling you that you must convert this time to hour, because if you are to get distance in kilometer, the time must be also in hours. Remember the question, it said, how far is E in kilometers? 20 seconds later, when he received the text. The first assignment you must put in place now is you back to dimension. There's something we call dimension, which says that 60 seconds give you 1 minute. And it's also saying that 60 minutes give 1 hour. So which telling you that 1 hour will be 60 times 60 seconds. That is 1 hour. So it means 1 second will be 1 hour over 60 to multiply 60, which is 1 hour over 3,600. In the comment section, you are advised to ask questions and make a comment. So now, if 1 hour, 1 second is this. You now have 20 seconds. 20 seconds will now give you 20 to multiply 1 hour over 3,600. So next I will convert. We now have 20 seconds is equal to 20 over 3600 hour. So that is the conversion. Now, in the point of this conversion, we have been able to convert it. So let's move further to this page. Let's move further, which we have been able to convert the value. Yes. So our speed given is 115 kilometer per hour. The time given is, we have converted the time to be 20 over 3,600 onto hour. That is the time. And we need distance. Remember that speed is equal to distance whole over time. So by crossing multiply, if you're able to cross multiply the value, we have distance is equal to speed to multiply time. That is it. Distance is equal to speed to multiply time. We have been having our speed and time. So distance is equal to speed. Our speed is this 115 kilometer. This per hour means to divide hour. That is just me. So our time is 20 over 3600 hour. So first thing which will happen is this, we cancel this. That hour we cancel hour. It will now remain 115 kilometer to divide 3600 times 20. Sorry, there's a 20 here. So by the time you multiply it together, we have our distance to be equal to 2,300 to divide 3600 in kilometer. That is how it's measured in kilometer. So by the time we now press calculator, when we press calculator, you can also do the same. Please, if you are online, send the message, please. Let me see your message. It is important. Okay. Why are we Hey, I have not even seen your message. Okay, good. Emanuela is available. And I want the message to stay. Okay. It says, sir, why are we multiply by 60 together? Okay. There's a question from that place. Is it from here? Please try to reply. If it is from here, let me know. Say we are multiplying. Yes, it is from the conversion. It is from conversion. That is the reason we are multiplying by 60. Ella. Because so the reason why we are multiplying by 60 is 60 seconds make 1 minute, and 60 minutes make one. Yes, we are able to reply you. The reason why we are multiplying by 60 is 60 minutes make 1 hour. Okay, you have good. Have you gotten it? Should I continue? I can see that you are online. Good. Okay, I should continue, no problem. So, yes, so our final answer will now give us, from here, we have 0 point. Please press it in calculator also for you to be accurate. So try to press it on calculator so you can be accurate also. That is basically much example about speed. I will see, let me still go find more question about speed. But now I'm also going to velocity. Okay, no problem. So I've able to, please, as we are also doing it, make sure you write notes immediately, because the note is many. So I want to use opportunity to clean the board so I can have a question from velocity. We start from velocity again. We solve more in velocity and distance. So let me have example. Use that time to write. Let me have an example on velocity. Yeah, correct. 0.63. Yes, 639. You are right. Good. So jot it. So let's start an example of velocity. Another example. I will give you an assignment today in physics. A particle accelerates uniformly from rest at 6.0 meter per second scale. I will soon push it up so you can see. For 8 seconds, and then decelerate, uniformly to rest in next 5 seconds. Determine write it as I'm writing because I'm solving it in another page. Determine the magnitude. Determine the magnitude of the deceleration. So you can see clearly from the question given, it said a particle accelerates uniformly from rest at 16.0 meter per second for 8 seconds, and then decelerate uniformly to rest in next 5 seconds. Determine the magnitude of deceleration. Please, by the time you're able to attend this class for just 6 months, the physics, chemistry, and maths, you will discover that you'll be vibrant in this course. You will realize that you'll be one of the best students in your class. I want to give some certain notation now to you that you must put in place. In physics question, a particle accelerates uniformly from rest at 6.0 meter per second scale for 8 seconds. For 8 seconds. Now, uniformly at rest, this thing, uniformly from rest, the meaning is this. U is equal to 0 meter per second. That is all. 0 meter per second. That's just the meaning. Anytime you see an object moving, please write it somewhere in your jotting notes. When you say anything come at rest, it means the initial velocity is equal to 0. And we were given the acceleration to be A is equal to 6.0 meter per second square. We are also given time to be 5 seconds. We are given time to be 5 seconds. So, now, we have so many formulas by the time you are reading your textbook, but this note, we also write it somewhere. So you too can able to compare the school note with this. You will realize that you are going to get it right. Now, we have been given time. So in this, there's one equation that we call we have 4 equations. I'm not explained such. I will just give you calculation in physics, write it, you soon get it clearly. V is equal to U plus AT. V is final velocity. U is initial velocity. A is acceleration. T is time. You try to write this somewhere. You write it somewhere. So what does this start for? Okay. You start from the velocity. I don't get your message, Emanuela. I've able to done some example in speed. Now I want to start the example in velocity. And this is the first example, which is a particle accelerates uniformly from rest at 6.0 meter per second scale for 8 seconds and then decelerates uniformly to rest in next 5 seconds. Determine the magnitudes of the deceleration. So please let me get your question clearly. Sir, what does this start for? I don't get that message. Retype the message, please. Okay. So try to write this. I'm starting the solution from the other side. Let me clean the other page. So let me continue from this page. Yes. Now, if V is equal to U plus AT, we have been given the V. We want to calculate the value of V. V is equal to okay, you see, write it. This is it. Write it. This is V is final velocity. U is initial velocity. A is acceleration. T is time. Write it. Initial velocity, final velocity, accelerations, and time. So that is what it stands for. So you're able to understand uniformly from at rest. So anything at rest, U must be equal to 0. So thanks for that question. You really get the question to ask. So now our V is equal to U plus AT, and we have been given the U to be 0. That is initial velocity, plus we have been given acceleration to be 6. We have been given the time to be 8 seconds. So V is equal to 6 times 8, which is equal to 48 meters per second. That is it. But we still need to understand one fact, that the question does not end in that place. The question still continues, which says that, you see, it says, and then decelerate. When it firstly accelerates, what they mean by accelerate? When a car, when your mommy is moving, okay, good. When a car is moving, it means it's accelerating. When a car is accelerating. But the moment a car is, when they are applying a brake to a car, it means it's decelerating. So you must able to identify the two. Now, the question now continues to say that, he said, since it decelerates uniformly, moment is start. Let me draw the graph for you. Make sure you draw it. We have a velocity time graph like this. It moves like this. So this is 48. This is under velocity. This is time in seconds. Velocity in meter per seconds. Now it moves to this. This is the first time given. 5 seconds. No, 8 seconds. Sorry, time. 8 is 8. Now, so it moved here from 8 seconds. That's what he's trying to explain. This graph, we call this one acceleration. So when it's now moving down, when it's moving up, this is moving up. When it's now moving down like this, we call this deceleration. That is the two analogy. When it is moving down, is deceleration. When it is moving up, so the moment is now moving up here from when it's at this point, when it's now coming down, this one, which is, this is 0 before, this is 48. When it's now coming down, this will not be initial velocity. For deceleration, for deceleration, U will now be 48 meters per second. You will still get it clearly later, but with the time. When it is moving up, it's accelerating. When it is coming down, it's decelerating. But when it is accelerating, initial velocity is equal to 0. But the moment it now say the question says that then decelerates uniformly to rest. Now, telling you that initial velocity as at that time equal to 48, which is highest before, but because it's coming down, it will now become 48. Now, so the final velocity will now be this. It will now be 0. V will now be 0. So final velocity V will now be 0 meter per seconds. So that is so. Now, in calculating the deceleration as at this spot, we have something like having V is equal to U plus AT. Our V is equal to 0. Our U is 48 plus our A when it is for the next 5 seconds, yes. So we have a 5. No. We need deceleration to multiply time 5 seconds. So that is how it proves it. Now, we now have 0 is equal to 48 plus 5a. So we have minus 5a is equal to 48. Minus 5a is equal to 48. So therefore, a is equal to minus 48 to divide by 5, which is equal to, by the time we divide it, we have a minus 9.6 meter per second square. So because it is that a is minus, it means is decelerating. That is just the meaning. It's decelerating. So the moment you see that your value of the value of A is minus, is telling you that it's decelerating. Is decelerating. You are doing board mass, yes. We can do board mass there, but we don't. The board mass here is simple. So if you are done with this, let me know. We can also have a meaningful example. Let me use this period to give you let me use this period to give you an assignment that you can able to work on. So let's have so are you done writing? Let me know so I can have another meaningful example. Let me write. I don't know. No. Mi ti ṣetán sir. Ṣé àwa ní the class ni? So I will give you the assignment. I want to end the class. Okay, you are done writing. Don't worry, I will send the assignment to group. For the physics class, it's just 1 hour now. Since we are not still many, to maximize our data. So it is 1 hour. So the pen. So I will send the assignment to the group section. So thanks for attending the class.